This second chapter focuses on mechanics. We are detailing the exact physical and chemical specifications that drive BluePeat's performance in the field. These rows represent thousands of uniform containers, all operating with a consistency that allows for industrial-scale production. This healthy green canopy is a specific biological result of the substrate's design. By mastering the 20 technical questions in this chapter, you can demonstrate the long-term viability of a project through verifiable data. BluePeat functions as a highly engineered environment where the grower maintains command over the root zone's exact conditions. Success begins with the chemical baseline. Blueberries require a precise pH range to facilitate the absorption of iron and zinc. BluePeat sits natively between 4.5 and 5.3, maintaining an acidic environment without requiring constant chemical correction from the grower. The base electrical conductivity is also kept very low, between 0.3 and 0.6. With no background salts or unpredictable organic nutrients, the substrate acts as a clean canvas for a precision hydroponic feeding program. When the substrate allows for nutrient uptake with zero interference, the plant can focus its energy on producing consistent fruit size and quality. By volume, a standard BluePeat container holds 40 to 50% water and an air-filled porosity of 35 to 45%. Combined, these metrics create 80 to 85% total porosity. Most of the volume is open space, offering minimal resistance to expanding roots. This physical balance provides the plant with continuous hydration while preventing the oxygen deprivation that often stunts root development. When water enters the container, it drains rapidly through the large macropores. This movement leaves the medium moist while drawing fresh oxygen directly into the root zone. For young seedlings, the low starting EC prevents osmotic shock. This allows sensitive new roots to establish themselves without the risk of salt burn during the first few weeks after planting. Compare BluePeat to standard peat moss. Traditional peat holds excessive water, limiting oxygen as it compacts. Because standard peat becomes waterlogged at the base, roots stay near the surface. BluePeat structure, however, allows oxygen to reach the bottom of the container. This combination of high air volume and stable acidity encourages the roots to utilize the entire volume of the pot, resulting in a deeper, more resilient root network. Most organic substrates decompose into a fine silt over time. BluePeat uses a specialized hardening process to ensure the particles maintain their shape, preserving air pores for 10 to 20 years. Commercial farms require structural stability that lasts through the life cycle of the bush. This 15-year guarantee secures a project's return on investment. In outdoor environments, BluePeat's drainage rate protects the crop. Even during heavy rain, the structure prevents water from pooling at the base of the bag. Every production batch meets European EN standards. This ensures that every bag on a farm, from the 1st to the 10,000th, responds to irrigation in the exact same way. When summarizing this for a client, the pitch is straightforward. It is half water, half air, salt-free, and stays structurally stable for decades. This uniformity enables precise calibration. A grower can predictably steer plant development and synchronize harvest timing across an entire property. You now have the chemical and physical data points required to address the technical requirements of large-scale blueberry production. Keep these 4 figures at the center of your technical discussions: pH between 4.5 and 5.3, EC between 0.3 and 0.6, a 40 to 50% water capacity, and a total porosity of 80 to 85%. eTuc provides a fully controllable hydroponic environment where roots have the oxygen required to grow. Now that we have covered the specs of the engine, the next video will show you how to manage it. We will detail the specific strategies for irrigation and nutrition timing. See you then.